Here are some examples of the poor installation of the sensors. For this picture, we can see much frequency noise due to the loss of the strain sensor. And this one also, it's bad data quality because the strain sensor is not installed properly. And this one. And we need to make sure the sensors is installed on the hardened concrete so that you can make sure we measure the real strain of the pile. Here are some common problems we're seeing from the data. Here, we can see that the proportionality is not very good. It is because of the wrong input of sensitivity factor of the sensors. That makes the force is much higher than the velocity. And for the proportionality problem, the parameter Ws, that is elastic wave speed, will affect the proportionality. Here is the correct wave speed, 3900. We can see that the proportionality is very good. But if we change the wave speed to 3500, we can see that the proportionality is not good now. The force is lower than velocity. And if we change Ws to 4500, it's similar to the previous example, which is the wrong input of the sensitivity factor. They all cause the bad proportionality. So from this equation, we can see that the Ws, the wave speed, will affect the proportionality. But elastic module E and section area A, they will not affect the proportionality problem. But can we say if the force is higher than velocity, it is definitely bad proportionality? The answer is no. Take this for example. We can see that the force is higher than the velocity, but the proportionality actually is good because we can see from the beginning, the rising point, to here, the force and the velocity, they meet each other well. And after that, they separate. And this is because of shallow soil layer is very hard. So the shallow resistance is very high. We know that the soil resistance will separate force and velocity curve. So the shallow high resistance soil layer will separate F and V at the peak of the plot. So for this data, the proportionality is good.